Hello everybody, welcome to Physics with No Big Words. This is Sebish and welcome to maybe the 6th video of the series. Today we will solve one basic question. We'll find the answer to one basic question. I have a pencil and I put some force to it. I don't like push it through, but I put some force to it. But I feel hurt at this point of where it has contact, right? But when I do with this thing, which is much wider than the pencil tip, with the same force, I am not doing any bias, like how whichever the force I applied there, I'm using the same force there, but I don't feel that much hurt as hurt I felt with the pencil tip. So why is that? In that case, we define a new term that is called pressure. We may all have heard the term pressure, maybe not in the physics sense, but in many other things, maybe academic pressure, financial pressure, and everything. And did you ever wonder why you feel that? We feel academic pressure and pressure of any sort because everything accumulated at once hits us in a single time. Like academic pressure is when you feel so clogged up with your academic backlogs, with your academic things. You have to do so much. You have to prepare for exam. You have to do today's homework, and you have to maybe do essays for your college. So many things all at once at a single place. So that's pressure, right? Similarly, in the physics context, the pressure is force, whichever force in a single area, in a small area. Get it? So the force that is hitting on an area is pressure. And then we say if the force is distributed in a bigger area, then the pressure is much less, because the force, if it's distributed in a bigger area, you feel that every area is feeling less and less force than if the force was all concentrated in a single point. So we get that, right? Why we feel less hurt and why we feel more hurt. It's because pressure. So pressure is defined now as the force in how much area it has been applied. So pressure, we can mathematically say like force that is divided by area, because it's the force that is applied in certain area, and then the force is divided by the area because the force is divided in that certain region. So pressure is equals to force over area is what we get it mathematically. And also the unit of pressure is Pascal, because it was formulated by the scientist Pascal. While talking about pressure, we'll also talk about liquid pressure. In liquid, if you throw a certain body, if a object you throw in a liquid, then that object will feel the pressure of liquid. Like liquid also can push or pull, right? Liquid can push the little ball or little object that you have thrown inside the water or a liquid. So liquid just pushes the ball from all its region. You may not see it like visually because it's too small of a force, but liquid does apply force, and then the force is then distributed to the all surface area of that object or a ball that you have thrown inside the liquid. So liquid also have pressure, and we call it liquid pressure. Liquid pressure has a different mathematical formula. Let's say liquid pressure is equals to it's derived from something, few steps of mathematical algebra. So I'll just tell you the result. So liquid pressure is equals to height or the depth at which the ball has been thrown times the density of the liquid times gravity. So HDG is liquid pressure. Okay, so we talked about liquid pressure, and last thing, we need to talk about pressure, and it's does it need context or not? So is pressure a vector quantity or a scalar quantity? So this is pretty complex, right? It's not as simple as force, displacement, and things like that. pressure sometimes needs direction to be justified, but sometimes it doesn't need enough justification. Sometimes your just 100 pascal of pressure is sufficient to explain that this is feeling a pressure of certain quantity. I mean, in the major cases it does not need where the pressure is being felt, because pressure is generally felt, I mean generally said that it's faced on the surface, so we do not really need it. So for now, let's phrase it that way: we don't need context for pressure. Pressure is not vector, it's scalar. So for now we need to remember these things. So meet you in the next video. Thank you guys.